Okay, so yeah, share. Okay, can you see my screen?
Yes, I can.
Okay, perfect. Okay, so we are already familiar with what quotient rule is, okay? So basically, whenever the question is about a fraction and we are asked to differentiate a fraction, we know we have to use the quotient rule. And what is the quotient rule? Let's say this is a fraction, u is the numerator, v is the denominator, okay? And you have been asked to differentiate it. This denominator would come here as it is. You have to differentiate the numerator minus numerator as it is, derivative of the denominator divided by the square of denominator. Okay, let's just quickly solve this example and let's move on. Okay, we are already clear with what quotient rule is, right, Ranjani?
Yes.
Okay, so what is v in this case?
V in this case is 2x plus 1.
Excellent. 2x plus 1. And what is the derivative of u?
2x.
Very good. And u is x squared
With
minus
x squared minus
5.
5.
Yes. And what is the derivative of denominator?
Derivative of denominator is 2.
Very good. Okay. Divided by 2x plus 1 whole square. Okay. We need to be clear. We need to be very careful with this minus sign to make sure that you use
You cannot
brackets
cancel.
properly. Sorry?
You cannot cancel 2x plus 1 and
Yeah. Exactly. Okay. So we have to simplify the numerator first. Okay. So it would be 2x into 2x, that is 4x squared plus 2x
4x.
minus 2x squared. We have this 2. 2 into x squared is 2x squared, and then this minus as well. Okay. Minus into minus 5 is 5, and that into 2 is plus 10. Right?
Yes.
2x plus 1 whole square. Okay. Right. So this would be 2x squared plus 2x plus 10 divided by 2x plus 1 whole square. So can we simplify further?
Yes, you can. The numerator.
Yeah, we can take 2 common. X squared plus x plus 5 divided by 2x plus 1. Okay. So these questions are very easy, and I have already explained you what the quotient rule is. But here I just wanted you to be, this question can come in your exam certainly. If not like this, then, they can say that find the coordinates of the point where derivative is 0. And you have to basically differentiate this function. And this is a very easy question. But you told me that you have time management issues. So you have to be clear with brackets, you have to be clear with steps, and you have to be clear with your writing. Okay, do not panic. Do as many steps as you feel like, but don't, just waste your time in doing in writing things like these, that d 2x plus 1 divided by dx. I mean, I personally would appreciate this, but when it comes to time management, we have to be very careful in these things. Okay.
Yes.
Okay, perfect. So now I have a good example, and I want you to just tell me the approach, then we can solve it together, okay? Find the coordinates of points on curve y equals x minus 1 whole square divided by 2x plus 5, where tangent is parallel to x-axis. I just want you to give me an approach to this question, as in, just a rough way of solving it. Just a guess. This is a random guess, if you can. So the
Okay,
question says, find the coordinates of points on curve. This is a curve, and this this curve has a point. Let's say this is the curve and there's a point. Obviously it would be here because the tangent at this point of the curve is parallel to the x-axis. So how, yeah, okay, yeah. So what would be your approach to solve this question? Any idea? No?
Yeah.
Mm-hmm.
So no, that will only apply for straight line, and this is not a straight line, so you cannot use the same gradient, or can you? Like
Yeah, you can. You know what? This is what how my drawing is. But the question says where tangent is parallel to x-axis. Okay, this is x-axis. Anything which is going to be parallel to x-axis would be a perfectly crisp straight line,
yes,
which would be horizontal, right? Anything parallel to x-axis is going to be horizontal. And when we talk about horizontal lines, the gradient of any horizontal line that basically would be parallel to x-axis would be 0. dy by dx is
yeah,
0 for both of these green lines because it is just like an x-axis, right? Just like x-axis.
yeah.
Okay?
So first I think you have to differentiate y,
Very good.
and
Then we have to equate it to 0.
then you'll find the x coordinates, and then you substitute that into the main equation to find the y coordinate.
Excellent. So step 1 is that, okay, if something is parallel to x-axis, and what is that something? This tangent. And what is tangent? Tangent is basically a line which we use in case of curves whenever we have to find derivative at a particular point, okay? If I ask you to find derivative of this curve, you will tell me a general equation, an equation which would have x as well, okay? You cannot tell me a fixed number like you would in case of a straight line. It is a curve. In case of curves, derivative is changing continuously. So when we talk about a particular point, we say that, okay, derivative at this point would be equal to the derivative of this line, and this line is tangent to this point. Like this line and this curve has one common point, and this is the point. So in short, this tangent is derivative at this point, at this point, okay? The point which we were asked in question. And what is the best part about this line? That it is parallel to x-axis. And when it is parallel to x-axis, the derivative is 0, okay? Yeah. So let's talk about the derivative. How are we going to differentiate this fraction? The quotient rule simply. So denominator would come as it is, 2x plus 5. Derivative of the numerator. What is the derivative of numerator?
The derivative of the numerator is
2. This 2
yeah
would
2.
come over here.
Yeah, 2x minus 1.
Excellent. Minus numerator would come as it is. And what is the derivative of the denominator? It is okay. You can take your time. Obviously, I understand this. It's completely fine.
Denominator will be 2.
Excellent. Because obviously here I'm trying to tell you that how you can do things quickly. I'm not telling you to skip steps. Never do that. Steps and method is the most important thing in maths. But you know, these things are something which we can just first write the formula and then just start with the solution. Okay. All right. Let's simplify things, and this would be square. Okay. So this is going to be 2x plus 5, 2x minus 2 minus 2, x minus 1 square. I did this step. And what would be the derivative?
The derivative will be...
Okay, look. This is what the question was. The question said, find the coordinates of points on curve. This was the curve.
It will be 0.
Yeah, excellent. 0, okay? So if I multiply this denominator, if I take it to this side, when I would multiply it with 0, it would be 0. So now I'm just going to talk about the numerator, right? So
Yes,
0
like
equals
expand the brackets.
4x square minus 4x plus 10x minus 10 minus 2 x square plus 1 minus 2x. Now look, I'm not skipping each and every step because I know that we are, human. We can certainly do calculation mistakes. So I would not suggest that you skip every step. Okay, minus 2 plus 4x. This and this can be cancelled. So this would be 2x squared. Can you help me? This is going to
Yes.
be plus 10x and minus
2. Oh no, minus 12.
very good. Minus 12. Okay. And now we have to make the factors. So what? Okay. So we need two numbers such that when I multiply them, the answer is minus 24x squared. And when I add or subtract them, the answer is 10x. So the two numbers are very obvious, right? What are the two numbers?
Values of x will be, I found the values of x will be 1 and negative 6.
Excellent. Okay. That was quick. I think you were doing this when I was asking you questions. Okay. So, okay, minus 6 and 6. And now we have to simply plug in these values in y. And we'll be able to find the point. Okay. So the final answer would be in the form y1 comma something and minus 6 comma the respective value of y. Okay.
Yes.
Right. So I don't want to just waste time on this. Is it clear? Is this example clear?
Yes.
Okay. So, questions are very easy. Questions would be easy. Yes, they would be tricky, but you need to learn these things. Okay, if something is parallel to x-axis, simply the derivative would be 0. Okay, and in 10 to 15 minutes, we'll see the case when something is parallel to y-axis. Okay, so yeah, this is done. We are done with the derivative of fractions or the quotient rule basically. Let's talk about the derivative of tan inverse. Okay, d by x tan inverse x. Okay, this is something which looks complicated, but it is very simple. One, oops, second. Sorry. Yeah, okay. So 1 plus x squared. Okay, I'll tell you how. This is how we derivate something when it has tan inverse with it. Okay, so here the question was that we were asked to derivate tan inverse x. 1 1, this 1 and 1, they are something which you would be using every time. The only different thing is this x. It could be that the question has 2x, 3x, 4x. Okay, whatever it is, that is going to come here with a square, right? That is d by dx tan inverse f of x. This is something which we had for x only. But if I talk about f of x, it is going to be 1 divided by 1 plus f of x square and the derivative of this f of x. Okay. So let's say if the question says that you have to derivate tan inverse 3x. So how are you going to do it with reference to this general formula? I need your help, Ranjini.
Okay.
So if we have f of x, we do it this way, okay? Derivative of f of x in this case is 3x. What is the derivative of 3x?
3.
Excellent. And 1 would come as it is, plus what is f of x in this case?
Tan inverse of 3x.
No, what is f of x? Look, this is f of x. The thing inside tan inverse is f of x.
So 3x.
3x, and we'll be having a square root, okay? Right. So obviously the question would not be that they ask you to simply find the derivative of tan inverse. They are going to use these derivatives in questions in different type of tricky questions, right? Just like the one we did recently in the previous example. But right now we are learning how to differentiate tan inverse, right? So if you have this x simply, you can use this and get this value. How? 1 over 1 plus function square. What is function in this case? X is the function, right? This thing is the function. Look, we have f of x over here. So this is the function. 1 over 1 plus f of x squared. F of x is x in this case. X squared into derivative of this f of x. The derivative of x is 1, right? So we can use this formula to find the derivative of different tan inverse questions. Let's see this question. So we had tan inverse 3x. F of x in this case is
3x.
3x. So the solution would be 1 over 1 plus 3x square into the derivative of 3x. The derivative of 3x is 3. This is how the answer was. 3 divided by 1 plus 3x whole square. Is it clear?
Why aren't we differentiating tan inverse, or
Sorry?
aren't we supposed to differentiate tan inverse as well?
Yeah, exactly. This is how we do it. This is how. Do
Oh.
you remember how we used to do derivate natural log?
Yes.
Ln x. So the rule was, let's talk
1 by
about f of x. So the rule was f dash x divided by, what was the rule? Do you remember?
Yeah, 1 by x, right?
Yeah, 1 by x in case of ln x. But here I'm talking about f of x. Because the question could be to derivate natural log of 3x, natural log of x squared. So you should know how to deal with questions with f of x. F of x is basically any function with x in it, right?
Yes.
Okay, so how would you do that in case of f of x? For natural log.
It will be f of x.
Okay, it would not derivative of natural log f of x is going to be 1 over this function as it is into the derivative of this function, right? Do you remember we've already discussed this?
Yeah, I remember.
Okay. So in this case, when we had to differentiate this natural log, the answer had, there was no natural log in the answer, right? This was the answer. F dash x divided by f of x. This was the answer in case of natural log. And we were differentiating it. Similarly, whenever you are asked to differentiate tan inverse f of x, this is how you're going to do. You would not be using any of the trigonometric functions in the solution, right?
Yes.
You will simply be doing it this way, 1 over 1 plus this function square into the derivative of this function. Okay. Ln f of x, right? Tan inverse f of x d by dx, d by dx. Okay. My first question is, what is this f of x?
That's any function. So
Yeah. Is x square f of x? Can x square be f of x?
yes.
Excellent. Can 2x be f of x?
Yes.
Can 2x plus 1 be f of x?
Yes.
Very well then. So when we talk about formulas in general, we use f of x. This is clear. Okay. Now, if a question has natural log in it and we have been asked to differentiate it, the formula is f dash x divided by f of x. It could be that the question was ln2x. So in this case, the derivative of this would be, what is the f of x in this case? 2x is f of x, right? This is ln, this is ln, this is f of x. So this would be f of x. F of x in this case is 2x and f dash of x could be 2. So the answer is going to be f dash x divided by f of x, 2 over 2x, that is 1 by x. Okay? Okay. So similarly, if you've been asked to differentiate tan inverse f of x, you have to do this f dash f of x, f dash x, 1 plus fx whole square. Okay?
Yeah.
These are the formulas. I understand that the fact that we cannot see any natural log in solution and we cannot see any tan inverse in solution is confusing you, but don't worry about it. This is how we solve these questions, and these are just the formulas. You need to practice these questions, okay? You need to practice some random questions like, okay, I have a question for you. Okay, take out a paper and tell me what would be the derivative of 3x plus 1 tan inverse 3x plus 1, and I'll write the formula. Okay, I'll write the general formula. Tan inverse f of x is f dash x 1 plus f of x whole square. Okay, now this is the question. Let's solve it.
Will it be 3 by 1 plus 3x plus 1 the whole square?
Excellent. Right? Do you understand now?
Yes.
Perfect. Are you sure? I can explain it to you again. I would not mind that, honestly speaking.
No, it's fine.
Okay, perfect. Okay. So this is how we differentiate these tan inverse questions. Okay, but here I have a little complicated case. Let's say if y is tan inverse 3x minus x cube divided by 1 minus 3x squared. Can you please find the dy by dx and do not simplify it? I don't want you to simplify it. Just tell me orally, okay? Don't write anything. Just tell me how are you going to do it. Right? Exactly. The silence is telling me that this is going to be something very, very complicated. Like first we'll have to find the derivative of this thing. Then, we'll first be finding the derivative. Then we have to divide it by 1 plus this function square. And then we'll be simplifying it. This would be something very, very complicated, right? But in such a question, we need to know that we would be using trigonometry, okay? How? I'll tell you. There is a very famous trigonometric identity. And don't worry if you don't understand it for the first time, okay? I am already assuming that you would not be able to understand it for the first time because it is complicated, right? So tan cube theta divided by 1 minus 3 tan square theta. This is a trigonometric identity, right? We know it. We know this. So can you...
tan 2 theta and not tan 3 theta?
Sorry?
Isn't it tan 2 theta equals to tan theta minus tan
no, this is tan 3 theta. It's tan 3.
Yeah, I must have got confused.
Yeah, okay. It's absolutely okay. So yeah, okay. I just want you to find a similarity between this in this part and this in this part. Something is similar in both of these questions. Like if you replace one thing with the other, you would be able to get the same thing. Just look at this and look at this. Tan theta x.
Yes, it's like
Yeah.
tan theta is being replaced with x.
Excellent. Okay. This is a trigonometric identity which we know. Okay. At the if you don't know at the moment, it's okay. In A levels, we are already given with a data booklet where we have questions. We do not have every trigonometric identity over there, but when you do past papers, you'll see the most important ones. So, and I will also be sharing a list with you. So I told you in the beginning that there would be some things which you will have to memorize. So in this question, never ever try attempting it this way. F dash x divided by 1 plus fx whole square. I mean, this is the formula. The answer would be correct, but it would take hours and hours to simplify it. Okay, and we can do this same question by using this in seconds. How, I'll tell you. Okay, so step one is to first basically simplify this thing. Okay, how are we going to do that? We are going to do that by simply substituting x equals tan theta. Why? Because we have this thing already. We know that if we will replace x with tan theta, if we'll have tan theta here, here, and here, so it would look like exactly this, and this is tan 3 theta. Once we have tan 3 theta in this, things would be really, really easy. Okay, so let's just do that first. Y equals tan inverse. I'll tell you, I'll explain you again. Don't worry. 3. Can you please help me in substitution?
Yes.
Yeah.
3 tan theta minus tan cube theta
Very good.
by 1 minus 3 tan square theta.
Excellent. Okay, and what is this? What is this whole thing?
This is f of x.
Okay, excellent. This is f of x, but this is also equivalent to something else. It is a trigonometric identity, right? I
Tan
just
3
told you.
theta.
Very good. This is tan 3 theta. And tan inverse into tan. This is tan's inverse. And this is tan. So whenever
It will
we
get cancelled out.
excellent. So we have 3 theta, okay? So we have y equals 3 theta. But still we are not at the solution. The question was to find dy by dx. And what have we done? We have this. So this is not the solution. We have to do some. What is theta then? If this is x equals tan theta, what is theta? Theta would be
F by tan.
okay, yeah, tan inverse x. Okay, I'll tell
Tan
you.
inverse x.
When we talk about the trigonometric identities, we don't do like this. Okay, we cannot take tan over there and say it's 1 over tan. We can
Yeah, so
take
we
it
tan.
to excellent. So it would be tan inverse, right? So here we are going to use the substitution. So y would be 3 into tan inverse of x. Okay, now things are good. Now things are really, really easy. Now you can use the general formula which we use for tan, and I want an answer from you now. So how would we do this? How are we going to proceed further? So we had y equals 3 tan inverse x. Now the function
Yeah,
is
now you
very
have
simple.
to
Yeah.
tan inverse of x will be
Yeah, just a second. You have been asked to find the derivative. So this is the question. Yeah. So now how are you going to take things further? Derivative of tan inverse x. What is this? I just told you, na, in the
derivative
previous.
of tan inverse of x is
Yeah. Just tell me the
x
formula.
1 plus x square.
Okay, 1 plus x square, and derivative of this function would come here, that is 1. So
1.
this is the answer. Okay. Perfect. Okay. So obviously, we are humans. We cannot learn hundreds and thousands of methods. Like we cannot learn that okay, if we have 3x minus x cubed, 1 minus 3x squared, we will be using this. No, it is not like that. The general formula for finding the derivative of a question that has tan inverse is this one. And what is this formula? You know, whatever you will be having after tan inverse is f of x. Step 1 is to find what is f of x. This is f of x. Step 2 is to find its derivative. And step 3 is to simply insert it in this formula, right? But here you could see that if we, start doing it this way, that we first find the derivative of this, that would take a good 10 to 15 minutes. And then if we find, f of x square, this is a fraction. Things would have been very, very complicated in this case. It is not like this that the answer would be wrong. The answer can never be wrong. Okay. But you would not be able to simplify it. We would be needing heavy calculators and things like those to simplify such question if we use this formula. So the tip was that simplification wasn't that easy. So here we had to use trigonometry. Okay. This tan inverse itself was telling us that, okay, a trigonometric identity might help us. And this is something we were familiar with. Okay, this is a very famous trigonometric identity. And if you know this, you would easily be able to know that, okay, if I have tan theta here and here, things would just like this, things would be like this, and you can easily say that this would be tan 3 theta. And once you have tan 3 theta here, tan inverse and tan would be cancelled. Y would be equal to 3 theta. And simply we were asked to find dy by dx. So you cannot proceed with this y equals 3 theta. You obviously need something in form of x over here, right? So we had this, our basic substitution. We had to find theta in terms of x. Simply theta was tan inverse x, and then we just simplified it, derivated it just the way I explained you earlier. Okay, is it clear?
Yes.
Are you sure?
Yes.
Okay, and now you know the reason why we did not do it this way and we chose this method?
Yes, because it will take a lot of time and
Yeah.
there's a trigonometric identity for it, so you can just.
Exactly. So, another managing tip, whenever you have to save time, and this is very obvious that if you start deriving, and if it's a 5 mark question, and if you start derivating this and then you square this and solve it this way, you would never be able to do it in 10 minutes or so. And so on, and it is not going to be a 5 mark question if you have to simplify it. So the 5 mark itself are telling you that no, Ranjani, you cannot do it this way. You have to do something else. Okay. So be vigilant, right? Okay. So are we clear with it?
Yes.
Okay. Let's talk about our last topic for today. Parametric differentiation. Okay. Such a good. Okay. Do you have any idea what parametric differentiation is? Any idea? Any clue?
No.
No. Okay. Obviously, because you have not studied this already, and this is why I'm here. So I'll be explaining. Okay. So this is used when x and y are in terms of t. Okay, now what is this t? I mean, we have just been looking at questions of this type. Y equals f of x, and this is what we have been doing throughout, right? This is what we
Yeah.
were playing with. But what is this t? Okay, I'll tell you. This t is the parameter, right? This t is the parameter, and this is what the question says here. You would not be having a y only. You'll have two functions. First function would be y equals something, second function would be x equals something, and both these functions would be in terms of t. But the question here would still be find dy by dx. Okay, we have been finding dy by dx for the last 2 to 3 days, right? But in those questions, things were like this. We simply had y equals f of x. Let's say we had y equals tan. The questions were of this type. It was either tan inverse, or it was natural log of x, or it was simply x squared. We were playing with these types of questions. But now we have two functions, y and x, and both these functions are in terms of t. So what would be your approach? I'll tell you. Do you know what the chain rule is?
Yes.
Excellent. We'll be using the chain rule. So if you have dy by dx, so how would you do that if t is the parameter?
Dy by dt
Excellent. And
times dt by dx.
very well done. Okay. So this is the only game in parametric differentiation, right? You'll be using the chain rule. The question would again be to find dy by dx, but you would not be given with something of this form. You would not be given with one function. You will be having two functions which would be in terms of another variable. So parameter, in case of parametric, obviously the question would not, okay, it could be that the question says that solve the following using parametric differentiation, or basically differentiate the following using parametric differentiation. But it could be that you are simply given with two functions of this sort and they ask you to find dy by dx. So the tip would be this t. This t would be the tip. If you have a third variable in a question where the question was to find dy by dx, you are simply going to use parametric differentiation. Okay, in parametric differentiation, you will have y, x, and t. It could be that you have u instead of t. Okay, don't get confused. Variables in the u, a, b, c, d, any they can use any alphabet for the variable. It is not a compulsion that you will be only be having t. But the thing you need to learn is the question would be to find dy by dx, but you would not be given with something of this form. You'll be having two functions which would be in terms of another variable, in terms of a third variable. It could either be t, it could be u, it could be s, any variable, right? This is how we are. I have not explained how to solve it, but this is how you will see that, okay, this is a parametric differentiation question and you will be using chain rule. How? I'll tell you. Do you understand so far?
Yes, but I still don't understand what parametric differentiation is.
Okay, okay, right, okay. So okay, let's just talk about it with an example, right?
How is it different from normal differentiation?
Exactly, excellent question. I'll tell you. Let me just then draw one. This is normal differentiation. This is parametric differentiation. We have been talking about normal differentiation. So what was the question type? Find dy by dx when y is either tan inverse of x, or y was ln x, or it used to be x into x plus 1 where we had to use the product rule, or maybe 2x plus 1 divided by x plus 1 square. Remember, we have studied how to solve these type of questions where we only had y and x, y and x, y and x, y and x. We had y equals f of x. We had over here the function was in terms of x. Now in this case, the question is going to be the same. you would be asked to find dy by dx when y equals something, x equals something. Y equals something, x equals something. I'll explain. Y of t, x of t. Let's say this is t square. Let's say this is 2t. Y of t. Let's say this is sine t. X of t. Let's say this is cos t. Okay. One question, two questions. Okay. Here we have to find dy by dx, but we have been given with two equations and this is a t. These are the two differences in normal differentiation and parametric differentiation. I have not explained how are we going to solve it. I'll explain it. But at the moment, you need to understand the difference first. Do you understand the difference? In this question, we had y, we had x. We had y, we had x. But here we are having two equations. In these questions, we just had this one equation. Then for question 2, we had this. For question 3, we had this. And for question 4, we had this. But here question 1 has two equations.
So it's
Question 2.
somewhat like, so is it somewhat like a simultaneous equation?
No. It is not. In simultaneous equations, we play with questions of this type. Y equals 2x and y equals x plus 1.
So there is still some similarity. It's both are y.
Yeah, exactly.
But
Both are
this-
y. Basically, both the equations are in x and y only, right? Both the equations are in x and y only. But here we have this third variable t. Wait, I'll move on to the example and then I'll explain you and then I'll come back. Okay. So the question is to find dy by dx, where y is 2 cos t and x is 1 plus 4 sine t. Okay. And over here, the function is in terms of t. So can I write y of t? Can I write it like this? Obviously, I
Yes,
can. Yeah. Say it again.
yes, you can.
I can because y and x are two functions which are in terms of t. When we had y in previous examples, when we had y equals tan inverse x, we used to write y equals f of x, right? So here these functions are in terms of t. Okay. Don't just care about what it means. I'll tell you. Okay, so you are to find dy by dx, and this was the chain rule. Dy by dx is dy by dt into dt by dx, right? This is what you have just told me. This is what you already knew, right? This is the chain rule. Nothing different, right? This is the chain rule, right?
Yes.
So what would be dy by dt? You have to tell me. This is y. What would be dy by dt?
dy by dt will be
We have cos
minus 2 sine t.
sine t. Very good. And what is dx by dt? This is
dx by dt.
yeah.
dx by dt is
Derivative of 1 would be 0, right?
0.
Derivative of any constant is
It will
0.
be 4 cos t.
Very good. 4 cos t. And what is dt by dx? Dx by dt is 4 cos t. So what would this be?
dt by dx will be 1 by 4 cos t.
Excellent. So we have dt by dx, we have dy by dt, we have dy by dt, we have dt by dx. So what would
to
be
multiply it?
excellent? Dy by dx would be minus 2 sine t into 1 over 4 cos t, and we can simplify it further. This is 2, this is 1. minus 1 by 2. What is sine by cos?
Sine by cos is tan.
Excellent. So this would be the answer, right?
Yes.
Okay. Now, I will explain it to you. Here we were not asked to find dy by dt, right? Here the question was to find dy by dx given that y is this and x is this. Now this is a totally different type of question. This is not something which we have been doing. We have been solving questions where we just had one equation, and that one equation was in terms of y and it was in terms of x. We have not studied this concept before. Here they have given us two equations. One equation is y equals something and the other equation is x equals something, and in both these equations the something part, or basically this part, has t. Okay, so we have tip number one, we have three variables. We have x, y, and then there's another variable which could either be s, t, u. The variable can be anyone, but tip one, three variables. Tip two, two equations. And tip 4, the question is saying to find dy by dx. So for such questions, we have to use the chain rule. This is what the chain rule is. And this is why the chain rule was invented. We use chain rule for such questions when we have three type of variables, right?
Okay.
So dy by dt into dt by dx. This basically, their product basically is dy by dx. I can simply find dy by dt. I can simply find dx by dt, and hence I can find dt by dx. Okay?
Okay.
Is it clear now? Please ask me if it isn't, please.
Oh, I know it's fine.
Are you sure? Because I have another example and you'll be doing it. Because
Okay.
you have seen this concept for the first time, and I cannot assume that you would easily understand it. It would take time, obviously. This is something which you have seen after 12 years of your studies. If you see something for the first time and if you have been doing something directly, obviously the questions were of this form, y equals f of x. You were not used to this. Okay, so let's not waste time and let's move to another example. Again, the question is to find dy by dx, and y is 4 tan theta. Okay, and x is 1 plus 2 sine square theta. Question 1 is, what is the third variable in this question?
Third variable is theta.
Excellent. Theta, okay? So the variable could be theta, the variable could be S, U, V, W, anything, okay? So you have to be quick, okay? So tip 1, we have 3 variables. Tip 2, we have 2 equations. And third thing, we have to find dy by dx. So this is clearly parametric differentiation. It is differentiation, but it is parametric differentiation because we have 3 variables, right? And when we talk about parametric differentiation, we know that we have to use the chain rule. So how are we going to apply the chain rule in this case? I want you to answer me.
So dy by dx will be dy by d theta.
Excellent. And
Multiplied by d theta by dx.
excellent. I'll give you a tip. Okay, just learn it this way. That if you cut, you can never do just cutting in derivatives. Okay, remember that. But it's just for learning. If you cut these, you would be left with dy by dx. Okay, so just learn it this way. The chain rule was not derived this way. There's a proper proof for it. Okay, so don't just think that I am such a bad mathematician. It is not like that. But just for learning, just learn it. Okay, learn it this way, that if you cut these d theta, you would be left with dy by dx. Okay, for the chain rule, right? Okay, let me just undo it, because if anyone sees that I'm cutting these two, they would really laugh at me. Okay. And what is dy by d theta?
dy by d theta is
Yeah.
the derivative of tan theta is sec square theta. Right?
Excellent, excellent. So 4.
So 4 sec square theta.
Very well done. And what is dx
D
by d
theta,
theta?
yeah, dx by d theta will be
Take your
2
time. Take your
cos
time.
2 cos square theta.
No. Wait.
No.
It is 2. It's okay. It's okay. 2 sine theta whole square, right? You know that. You know this, right? If we have a square here, I can write it like this. Okay? You know that, right?
Yeah.
Okay. So this is, just treat it like a bracket question. Treat it like a bracket question. And how do you do bracket question? This 2 would come as it is. You multiply this 2, the bracket part would come as it is, and the derivative of this bracket part would be cos theta.
4 sine theta cos theta.
Yeah. Okay. Never ever do this. Sine square theta is not cos square theta. The derivative of sine square theta can never be this. You have to deal with these questions this way.
Okay.
You need to think of the U method. By U method, I mean the substitution method or the bracket method, where we just multiply the power as it is, keep the bracket thing same, and the derivative of bracket thing would come in. Okay. Right. So this is dx by d theta, and what is d theta by dx? This is dx by d theta. So what is d theta by dx?
D theta by dx will be
Yeah. Look, this is dx by d theta. So
1 by 4 sine theta cos theta.
yeah, very good. Okay. So what would be dy by dx? This is the formula. You simply have to substitute.
Yeah, so it will be 4 sec square theta by 4 sine theta cos theta.
Very good. And you can simplify it further. How would you do the simplification? What is sec theta? It is 1 over cos, right?
Yeah, 1 over cos theta.
So this would be 4 and 4 would be cancelled. So this is going to be 1 over
cos 2
sine
theta.
theta into, this is cos theta. So cos theta into cos squared theta would be
Cos cube theta.
cos cube theta, right? Okay,
Yes.
this is the answer. Right. So I'll repeat a few concepts right now. We are clear with what parametric differentiation is?
Yes.
You need to look at these 3 clues in question. You have to find these clues, and then you will simply know that, okay, this is a question which would be solved through parametric differentiation. And when it comes to parametric differentiation, chain rule. Never forget that. This is the chain rule. This is the chain rule, okay? dy by dx equals dy by whatever the third variable was. In this case, it is theta. In last case, it was t. So here, since it was theta, we have dy by d theta into d theta by dx, okay? dy by d theta is was very easy to find. We simply differentiated this y with respect to theta. D theta by dx was also very simple. We simply had to find dx by d theta, and we had to find its reciprocal. So this is how we did. This is something which I was not expecting. I'll tell you why. Whenever, okay, we are clear with the parametric differentiation, right?
Yes.
So let's just talk about Okay, so what if the question is find the derivative of cos square 4x? How would you attempt this question? Remember, whenever you have been given, whenever you have a differentiation question where you have a trigonometric identity and there's a square, you don't have to learn too many things. Just remember that this is going to be solved by the bracket method. First, rewrite the question. Cos 4x. This square is nothing but it would come like this. This square can be written like this, okay? Divided by dx. Is it clear? And now if you derivate this question, this 2 would come as it is. The bracket part stays the same. And the derivative of what we had inside the bracket would come minus sine 4x. And what is left, Ranjani? We have to write something else over here.
4.
Excellent. So the answer would be minus 8 cos 4x sine 4x. Right?
Yes.
Okay. So today's concepts were a bit complicated and I had to continue the previous example because I wanted to link it with a trigonometric question, with a question which belongs to trigonometry. But it's okay. I'll be definitely doing it in the next class. For now, I just want you to know that we are clear with the quotient rule. D by dx, u by v, things are very easy in this case. Okay. Learning one was that whenever something is parallel to x-axis, the derivative would be 0. Okay. Then we discussed tan inverse and d by dx, tan inverse f of x would be f dash x divided by 1 plus f of x whole square, right? But when the question looked like a trigonometric identity, or when you could see that, okay, if I replace x with tan theta, because it is tan inverse, right? In that case, we use that trigonometric identity and then we solved it. Okay?
I can't hear you. Your voice is breaking.
Yeah, can you hear me now?
Yes, now it's fine.
Yeah. So simply we just use the trigonometric identity in that case, okay? The third part was the parametric differentiation. We had those 3 clues that we need 3 variables, 2 equations, and the question should be dy by dx. We were clear. But the last thing, which was not a learning, but I just got this idea that you are not clear with the differentiation of this. Okay, so I have a plan. I'll be sharing a good number of questions now because our next class is on Saturday. And I want you to solve those questions and please share them on WhatsApp. I need to see.
Okay.
I obviously
Okay,
I
I'll
need to
share.
see. Okay.
Okay.
Yeah. And I'll solve the last question. I'll share it on WhatsApp with a voice note now in an hour. And you can look into that. Other than this, I will give you 10 questions, but the questions would be a combination of sine square, cos square, tan inverse, parametric differentiation, quotient rule, product rule. I want you to do them. You'll have 2 days, right? So if you spend
Yeah.
2 hours tomorrow and then on Friday, you can easily manage them. Because these things need practice, and it's good that this is December and you have your mocks at the end of January. So it's good that we just
Yeah.
practice at this point rather than practicing it later once you are done with the syllabus, because at that point you would not be clear with the concepts. You need to practice right now just so your concepts stay in your mind. Okay, so I'll share 10 questions in an hour as well as the solution of last practice test. Okay, is it clear?
Okay.
Okay, so don't, are we clear today? Is there anything you want to ask?
No, it's fine.
No, I think you have to ask something. The no had, a yes or no.
No, it's fine. I
No, you can
understood everything.
ask. Yeah, I think if you want to ask something, please ask me. I am free. You can ask me. I would not mind.
I don't have anything right now
Okay, okay,
to ask.
okay, okay, perfect. Okay. So take care. Bye bye.
Bye.